Okay, so I'm drawing something that's roughly going through as a perpendicular line through, come on, through line M. So maybe about like that. Okay. From there, you want to extend through it. So, well, let's see. I might as well clone this. So whatever length this is, obviously my t on the other side, that mirror image on this point, so I should be looking at that point right there. My t should end up there. So, you could use a ruler, I guess. You could use a ruler and mark some of these things off. So I put the point as a reflection on the other side, and so you can see how wrong I was. But you go there, and this point on T should end up right there, so it goes off the screen a little bit. And I do apologize for that. So actually, let me just rough it a little bit and bring it back down some. Oh God, I hate when this thing messes with me. Let's bring it back down a little bit, and let's just pretend it was right there. Now here's the important part. Now what I have to do is look at, I'll look at another point on T. Let's look at these 2 points right here. From this top right part of T, in my pre-image, to this top right part of T in my image. Okay, this distance, let's call it x. This distance is a translation. Recall that reflecting across one line, then across another, and these are both parallel, means it's the equivalent to a translation. Now, the translation, this x right here, this is twice the length of the distance between my 2 axes of symmetry. So that x is twice as much as the length between this and this. And remember, you want to draw distances perpendicularly, so I'm trying to go as closely as possible. So let's call that distance y. So when it says describe the resulting translation or rotation, I'll just underline translation because that's what it is. This is a translation. And it is where t, let's just call this t prime, just to help us out, where the distance, I'm not sure exactly how you want to describe it, but the distance from t to t prime is twice the distance from lines M and L. So in other words, 2 times y equals x. If I multiply this length by 2, I get this length x. And that is an important thing you have to remember. Now, we've done problems where we started, like say we started with this t, we reflected it across here, and we reflected it across there. And that's where we'd end up. We have never done one yet, at least as homework, where we reflect across one line all the way across the other like that. So at least you get to see a problem like it, and you get to see a description. Okay? And finally, the last problem. And this one will be a little tough, actually. The 2 figures are congruent, which means they are isometries, which means one's a mapped image and all that stuff. Name the isometry that maps one over the other. The isometry, in other words, name the transformation type. So is it a reflection, a rotation, a transform? I'm trying to say 2 things at once. Reflection, translation, rotation, or glide reflection. I want to do black onto blue, and I don't think I can actually shift these images, so I will concern myself with points. So, and I'll do my own rough drawings. So remember what a direct isometry is and what an opposite isometry is. That's the first way that you can really narrow these down for yourself. So let's do direct isometry first. I think that's always the easiest to say. Let's pick some relative points, like this point and this point here. Can I do a translation or a rotation to get these 2 points maybe rotated that way and map them onto here, or to just translate it over and map them over in some sort of way? Well, as you might see, in fact, let me start naming these. Let's call this A and B. Where's my A prime, B prime right here? Keep in mind this is 1 over 1 up, 1 over 1 up. The only place that has that slope anywhere on this shape is right here. So this is the only place that has that same shape. And there's no possible way that I can rotate this down this way and have that. It looks like even if I did, it would be drawn right here. So it would be going the opposite way. So it looks like this is not a direct isometry. It looks like it's an opposite isometry, which means this either has to be a reflection or a glide reflection. Now, the easiest way to figure out, well, not to figure out which one it is, but the easiest way to do a reflection is to find an axis of symmetry. So the axis of symmetry obviously is not just a vertical line, like so, because if I reflect it over, then it would end up looking, something like this, right? Something like that. And it's not just a horizontal one, like so, because then it would just be flipped over like that. Okay, so it looks like you need to do some sort of glide. You need to move it over, and it's not also something where it's just skewed that way, because simply because it isn't. But you consider, what do you reflect over? If I reflect over here, okay, so far all looks good. But now when I reflect this piece over, it's going to be up here. See, this will end up being, I don't know, somewhere up there like that. And then you end up doing whatever. So we need to glide and reflect. So the one, this problem probably wouldn't be asked of you to solve on a test. But a glide reflection means that wherever I translate, let's say I translate this way, I need to, in fact, I do believe that's what the answer ends up being. But if I glide and translate this way, my axis of symmetry has to be parallel to that. So my axis of symmetry would have to go that way as well. And I do believe that that's what we end up doing here. So I do a glide reflection. I want to just connect these pieces so they look like mirror images of one another. And like I said, when I made these, I think they're all disconnected. So let me start to take this piece by piece. I think it's 2 triangles and a square. Let me take this piece by piece and glide this way. I'll go, consider this point right here is equivalent to this point, right? If this is A and this is A prime, I want to go 2 units to the left and 2 units down. So if I think of that like a translation, that's like -2, -2. So I would do that with every point. So even with this point, I'd go 2 units over, 2 units down, and that's where it would end up and everything. So let me just take this piece by piece. I just got rid of that. Let's go -2, -2. Take this piece by piece and try that out. So I'll go, like I said, these are all individual things here. Like that. -2, -2, -2, -2, and -2, -2. Okay, see, now it looks more like something that we can flip over. Yes, it is an opposite isometry, but at least now we can reflect it across something. You have to figure out which line it is. Now, we should know what the slope of the line is because it should be the equivalent to going over 2 and going down 2. I should say going down 2 and going over 2. If I go down 2 and over 2, that's the same as going -2 over -2, which means my slope is 1. So, the slope goes like that. I'm going up 1 over 1, up 1 over 1, or down 2 over 2 if you want to call it like that. So that's what I want to reflect it across. So we have to find out what the slope of that line is. So the best way to do it is we have a slope. We have y equals 1x plus b, or x plus b. We have to find out what this y-intercept is. And that can be solved by picking any point that is on this line. Now there's a point right here, which is 1, 0. I can pick that point, plug in 0 for y and 1 for x into this equation, and solve for b. And I'll get 0 equals 1 times 1 plus b. 0 is 1 plus b. Subtract 1 from both sides, I get b equals -1. So my equation of my axis of symmetry is y equals 1x, or x, minus 1 plus b. b is -1, minus 1. So there's my reflection, and here's my translation. So again, what we did was we mapped this across. We had a black figure originally up here. We had to translate it down to reflect it. We decided we had to do a reflection